different innovations, different challenges and opportunities in this regard. And we have now the chance in this first session this afternoon to learn more from the business sector here in India. Before very briefly summarizing a few context information, I would like to emphasize that, as you can see, I have 7 or then later 8 distinguished colleagues here on the panel. So we have quite a challenge when it comes to be aware of the timekeeping. So we asked our distinguished speakers to come up with a 10-minute intervention. I will try to be helpful in one or the other ways when I see, when I have a look on the clock and I see that we are in danger of shooting, then you will hear this little bell. Like this. That is a wake-up call, kind of. I don't want to be rude, but I think we should also have some time to discuss and then give you, as the audience, the overall opportunity to come in with questions, also with statements, but that at a later stage. So, and I, after my little context giving, I would like to ask the speakers, as per the given order in the program, to come up with the interventions, and some of them has PowerPoint presentations and will help us to frame especially the business perspective on the challenges and opportunities in the RAC and Cold Chain sector. I think when we go back, also what was briefly described this morning, also from a European perspective as experience, but also from a global perspective and some of the Indian insights, we can see that there are, in addition to the available and potential technical options we already mentioned, we see an increasing public-private interface consisting basically of 3 areas. What I would like to mention, that is policies and regulation, networks among stakeholders, which is probably something we can be more explicit throughout the afternoon, and of course the role of business and for example company-driven innovation processes. And for the EU, I think it's fair to emphasize again that the kind of regulation that was introduced basically in 2006 on the F-gases introduced a number of far-reaching changes, also becoming effective most recently in 2015. Based on the stipulations, the regulation will help to cut the F-gas emissions by 2/3 in 2030 against a 2014 baseline. And I think in order to support this process, we can see quite a number of support instruments for producers and operators in complying with legal stipulations, like guiding documents, frequently FAQ documents, calculation tools for converting F-gas emissions value into CO2 equivalents. So there is quite something out there, and in terms of regulation, that we also bring to the table. Talking about networks, it's potentially also an area where some of the member states' initiatives are coming in. We already mentioned that there are, from a climate finance perspective, that there are ongoing initiatives, for example, by the German government with the support for the Green Cooling Initiative. And this is implemented also by GIZ, to provide sector-specific data and material for actors from the private as well as from the public sphere. A global green cooling network is established to accelerate the transfer of environmentally friendly technologies for refrigerations and air conditioning in developing countries. And there we have the element of showcases of best practice companies which actively push towards decarbonization of the refrigeration and cooling sector. So there are are some further examples when it comes to company networks at the European level. For example, the European Federation of European Heating, Ventilation and Air Conditioning Association. These kind of associations have also been very helpful by issuing various technical guiding documents for complying with newly stipulated standards, and they play an important role. And we may also refer to Euromon, initiative led by European companies, institutions and individuals, which seeks to promote and increase the use of natural refrigerants. It aims to create awareness for available options, but also showcases a number of in-depth studies, publishes a magazine on best practices, and maintains a product directory of producers for low G global warming potential refrigerants. And those, what this sums up to is basically that we have an enabling environment and try to create an enabling environment for some companies. We do not focus in this session so much on European examples. There are quite a lot from different countries. To mention for example, Swedish manufacturer Electrolux with some also innovations and research and leading the company to develop an F-gas-free domestic refrigerator and with very low energy consumption. There's a Danish company, Johnson Controls, we may refer to, also with a specialization in the use of natural refrigerants, going to, and then moving over to Austria with AHT cooling systems, or in France, the Cooltech application, technology that tries to come up with technologies not using any refrigerant gas whatsoever, and also helps to create significant energy savings. And coming from Germany, also maybe a last reference is that of Linde, a group that that has developed a number of low global warming potential refrigerants applied across the entire HVAC sector. There's an instance for the automotive industry with a concept of 744 as an environmentally friendly refrigerant, and so you can see quite different examples that help to outline or outline what can be the potential role of companies. Nevertheless, I think there are quite a number of questions open, and I hope to learn this throughout this session more about how Indian companies are dealing with the potential implications of a global deal on HFCs that we learned about this morning, and what the Kigali Amendment actually means for business. And so I'm happy to give the floor now to Anil Gulangiaka. He is a president of the Association of Ammonia Refrigeration, and we already learned this morning how important this refrigerant is. Thank you.
Good afternoon, everyone. After lunch, the first topic, so I hope I'll be able to keep you awake. Since I'm talking on ammonia, I hope it will be possible. Anyway, this cold chain sector in India and ammonia refrigeration, this is a topic. Let's see how we are going about it. As we all know, the government of India has taken a great step and supporting the cold chain sector with providing various policies, and everyone knows about it that there is a great support of government for formulation of cold chain for the obvious reason is to save and prevent wastage of food. The 10 minutes time is given, so I am pointing out only the important points of each slides. I'm not going to read the slides. Information is already on the slides. The refrigeration is most important part of any food processing line, and ammonia is a refrigerant which is not new to India. It has been used in India for more than 100 years, and the industry size is about 300 million US dollar by now. But the difference is 50% is the organized sector and the 50% is unorganized sector. What do I mean by that? Organized sector means the companies which have a class of companies like the multinational companies in India, and they work with certain standards, procedures, safety norms without asking them to follow. And there is unorganized sector means there is an individual contractor. From operator level, he becomes a contractor, he becomes a designer, and he starts building up the plants. And like that, we have plenty of unorganized sector people in India who are building ammonia plants with their own knowledge and capacity. So this is the difference in India, that we have organized sector as well as we have unorganized sector. We have state-of-art plants which are fully automated plants with 100% safety as per international standards, and we have exactly opposite picture of the plant also. So we have both kind of plants. Then the challenges are much more. And average growth of ammonia refrigeration industry is about 10% every year. Sometimes it is 15%, but on an average, for last 10 years, 15 years, the growth of this industry is 15%, 10%, sorry. But what I mean by ammonia industry, I'm talking about industrial refrigeration, the large plants, for all the applications. What are all the applications? What we are saying is cold storages, dairies, beverages, breweries, and food processing plants for meat, vegetable, poultry, etc. So all these applications in India, ammonia is extensively used because the size of the refrigeration system is large, the capacity requirement is large. We are already using natural refrigerant ammonia in most of the cases. You can say almost entire food industry, 90 to 95% plants are built with ammonia. What are the strengths of Indian refrigeration industry pertaining to ammonia? We have good manufacturing companies in India. We have multinational companies, they have offices in India, they produce in India. We have good skilled engineers. We have a knowledge of designing of plant, we have a knowledge of maintenance of plant, and we have entire material equipments available in India which are produced locally in India. If we decide that I don't want to import anything, still we can build a plant in India which is of international class. These are our strengths. What are our weaknesses? Our weaknesses are the trained operators for this industry, safety practices and for the refrigeration industry. See, since we don't have any rules and regulations, or we have very minimum rules and regulations, or they are not forced to use it. So unless it is forced, we have seen that it is not followed. So we have safety practices lacking. Unorganized sector, as I explained, they design the plant as per their limited knowledge. Then, like boilers, they have a factory inspectors who go and inspect, but for refrigeration system, it is not a package, it's a system which is designed on case-to-case basis and assembled at site. So specialized inspectors from the government side, they are lacking, or there are factory inspector acts and everything, they go to the site, but the logic used is mostly for the boiler. Like pressure vessels has to be hydraulically pressure tested for a running plant, which is technically impossible to do that. So like that, there are some systems, procedures and inspection lack. There is a lack in that. Then non-availability of one consolidated standards. We have some standards available, but they are 1962 standards, 1980 standards, which needs to be upgraded, updated, and they are for individual components. There is no individual standard available which tells you what are the factors to be considered for selection of equipment and safety.